and welcome to Solidworks Station. My name's Stuart, and in today's tutorial we're going to look at this CSWA sample exam question. A few things that we need to look at here. We've got an A value first of all and a B value, which we'll come to later on. So that's important, as we could use global variables at the start to put these values into, just in case they changed. We've got a material that's been specified as ABS PC, so a combination of ABS plastic and polycarbonate. The material density has got to be 1070 kilograms per meters cubed. We're using the unit system of mmgs to 3 decimal places. Our part origin is arbitrary, and we've got our A and B values. The question is asking us what is the overall mass of the part in grams. Now it's asking us for it in grams, however it's asking for the material density in kilograms. So we're going to have to look at some of the options within SolidWorks to get this right in kilograms and get this right in grams as well. So by the end of this tutorial, if you're struggling with any of the work or you feel that you need a bit of additional support, please get in contact by dropping a comment in the comment section below this video, and I will be more than happy to help out. Best of luck everyone, and let's get started. Okay, so I've got SolidWorks open. I'm going to go to File, New, and create a new part. The first thing I'm going to do is going to go into my Tools, Equations, and I'm going to put in a global variable of A, which I know was equal to 140. Press the Tab key to go across, and B, I know had a variable of 64. So I can put 64 into this box here and press Tab, and we're ready to go. If I had any more, I could keep adding them down here in the global variables. However, I've only got the A and B values, so I'm ready to move on. So I'm going to move into a right plane, normal 2, and I'm going to produce a sketch of a line that's going to go across like so and up at an angle. Okay, I'm going to give these some smart dimensions, so I'm going to go to Smart Dimension. I'm going to Smart Dimension this line to start off with a global variable. So I'm going to do backspace, go into my global variables and select the 140 for A. Okay, and green tick. I know that this angle here is 60 degrees, so I'm going to go to Smart Dimension. I'm going to click on this line, click on this point. Let's do that again. Smart Dimension, click on this line, click on this point, click on this arrow, and I get this degrees. Okay, if you wanted a different one, you could click on this arrow. Okay, this bottom one. Okay, etc. Okay, but we need this one, and we know that this is 60 degrees. That's just a little tip in SolidWorks. Some users end up just clicking one line, then clicking the other line. Okay, but you've got an option. Okay, if you just click on a line, click on a point, you get to specify which angle that you want. Okay, let's move on, and let's dimension this line, which we know is 90 millimeters. So let's dimension this up. Perfect. The reason I'm not going to do this line here is if we look, this has actually got a material thickness here of 18, where this has got a material thickness of 19, so they're different. So we're going to leave this till later on. Okay, so the next step here would be to extrude this. As we've just drawn it as a line, it will be a thin feature. So we're going to go to Features, Extrude Boss Base, and we're going to extrude this 64 millimeters. However, this is a global variable. Okay, if you remember from our drawing here, B was 64, okay, which is the width of this part. So I can use a global variable here. So D1, okay, is a global variable of B. like so. And my thin feature, okay, is my thickness, which is 19. So I can put 19 in here. I'm going to go mid-plane with this one, like so, and we're ready to go. Perfect. So from here, all I need to do is click on the green tick, and I'll have that extruded part. Control 7 on your keyboard, and you'll get a nice isometric view of that. From here we need to look at producing this angular bit here that comes up at 90 degrees, and we've got a few dimensions. So we know that it's at 90. We know that the width of this part is going to be B, which is 64, and we know that the length of this line that we're going to draw here is going to be 51 plus the 32 for the radius of this arc. So I'm going to go into a right plane, normal to, sketch. I'm going to sketch a line from this point here. I'm going to try and keep it at 90 degrees the best I can, and left click. Then I'm just going to check with a smart dimension from here to here, and I need to change it to 90 degrees. Okay, from here we can smart dimension this line at 83, and we can go and produce now a extrude, and we know that this value is a global variable of B, so we can go to global variables and select B, and we want it to be not blind but mid-plane. And then we've got the thin feature. Now we've got 19. We know that this is actually 18, so we can go ahead and change that. So I'm going to put 18 in here. It's going in the right direction, and green tick. Control 7 on your keyboard for your isometric view. Okay, what we need to produce now is this fully rounded fillet, what we've got on the end here, and that's really simple to do in SolidWorks. All you need to do is go into the fillet command in the features tab. So fillet, you choose the last option, which is the full round fillet, and you'll get 3 colours, blue, purple and pink. The first selection is going to be this side. Let's click into our next face. It's going to be this top side, and then let's click on the bottom colour, and that's going to be this side. And we'll get a nice preview there of our fully rounded fillet. We know the distance here was 64, half of that would be 32, so this radius here is going to be 32 millimeters. And we can click on the green tick. Okay, so the next bit I'm going to focus on is this bit here, and a little slot that goes down here as well. I'll just show you on here. So what we've got is this kind of cutout section here that I've got some dimensions for. So this 11, this 42, I've got a 60 degree angle in here, and 60 plus the 30 would give me a 90 degrees. Same on the other side, and I've got a 6 millimeter gap here that I need to put in. I've also got some dimensions for the circles, so I've got this circle here that I know is 32, and then I've got this other one, this other circle, okay, which is 19. So let's go into SolidWorks and let's model that up. So I'm going to click on the face I'm interested in, and I'm going to go normal to. If you don't want to press the normal to button, you can just click on the surface and do Control and the number 8 button on your keyboard, and that will have the same outcome. From there we're going to go and create a center line, and we're going to produce that straight from the origin all the way up to the center of this arc, and then we're just going to sketch in that shape that we've got. Like so, and we're going to put in the dimensions. So we know that this was 42. We know that this gap here was 11. We know that this gap here was 6. And I'm going to make this line and this line equal, and I'm going to put a 60-degree angle in here, like so. And I want from this point and this point, yep, is 11 as well, just to double check. From here, let's put our circles in. So we've got a circle and another circle, one at 32 and one at 19. I'm also going to offset this centre line by 11mm each side. So you can see here that we've got a 22 gap. So if I offset my centre line 11 and 11, I can use those two lines to cut out that particular feature. So I'm going to press my S key. I've got the offset command here. You can type it up here, offset, if you wanted to, in order to use it. And I'm going to put in 11mm here, bi-directional, and click on this line. Green tick. I'm also going to convert this arc to an entity. So I'm going to click on this arc and convert entities, just so I can use that later if I need to pick a particular region. Okay, the final thing I'm going to do is just going to line these circles up. So I want this midpoint and the end of that arc to be horizontal. Okay, so the next step, once I've got this sketch complete, it's a good idea just to sketch everything all as one in one sketch, just to make the feature tree here not as long. The less sketching you can do in here, the more you can do a sketching in one particular sketch as opposed to creating several sketches, the better, because it just minimises the length of this particular feature tree. So from here we can make a extruded cut. Let's go into extruded cut and we're going to select the contours, the regions to start off with. So I'm going to pick up this trapezium at the bottom that we've used, and we're going to say through all for this particular one. Okay, like so. And green tick. Okay, if I click on the screen now, you notice the sketch disappears. So to get that to reappear, just expand the cut extrude, click on the sketch that you've done, you can see it reappear, and just go into extruded cut again, and we can reuse this sketch. The next region that we're going to use, we're going to pick up these contours, and we're going to go blind by, let's just check on here, let's just zoom in. Okay, 6mm. So change this to 6 and green tick. Okay, the sketch has disappeared again, so just expand, pick up the sketch, back into extruded cut, and our next bit is this bigger circle. So we're just going to pick up the contours for that and just check our sketch, zoom in. Okay, you can see here the 32 one is saying it's 9. Okay, 9mm down. So let's change this to 9 and green tick. Reuse the sketch and extruded cut. The final one, this 19mm diameter circle, and we're going to choose not through all. Okay, through all will go through the whole of the shape. That's not what we want to do. We want to go to up to surface and click on this surface at the back and green tick, like so. Control 7 on your keyboard for your isometric view. Okay, we're going to look at now producing the two circles on the underside here. We know that these are 30mm for the diameter. We also know that the distance between each, okay, is 29, okay, centre to centre, and 28 from this top edge to this centre. So from the top edge to the centre of circle 1, 28, then the centres are 29mm. So let's put those in. I'm going to click on the face I'm interested in and normal to. I'm going to sketch a centre line from this top edge here all the way down to the bottom. Grab a circle, pop 2 circles in, doesn't matter where for the time being, just as long as they're on this centre line. Press the control key, select this circle, hold down control, select this circle. Let's make these equal because they're both going to be diameter 13. Smart dimension one of them, and both of them will update. Okay, 13 millimeters. Okay, that's actually at 12.99. Although it says on the screen 13, it's because it's rounded it up. So just be careful of that. Okay, so it's actually 12.996. Just be careful. Okay, put that as 13 mil, and both of them will update. Okay, from here we know from the top edge. Let's just check that. Yeah, from the top edge is 28 and centre's 29. Okay, so smart dimension from this top edge to here we know is 28, and then we've got centres of 29. Perfect, and from here we can go to features now, extruded cut and up to surface, and click on this side like so, and green tick. Okay, so the next thing that I'm going to look at is producing this last bit here. So in order to do that, I'm going to have to create a new reference plane. Now we're going to have to do a little bit of adding up here, dividing, in order to get the right location for the reference plane to sit. So I'm going to use this 19, this 29 and this 19. I'm going to add those together to give me 67. I'm also going to use that 67 and divide it by 2 to get my centre point, okay, which would be 33.5. However, I've not taken into consideration this gap here, which is 14 millimeters. So I need to do 19, 29 and 19 to give me my 67, divide it by 2 to get my centre, which would be 33.5, but then with that 33.5 I need to add this 14 to get the exact centre here where my plane is going to sit, which will be 47.5 millimeters. So let me just show you how that works on SolidWorks. We're going to click on this plane, we're going to go to reference geometry and plane, and at the moment the plane is going this way, so we need to reverse the direction on that. So if we go flip offset, it will go the other way. So if I just put in the calculations here, so it would be 19 plus 19 plus 29, enter, is 67. Where this is sitting at the moment, okay, is 67 millimeters along this line. Okay, we've not taken into this into consideration this 14 yet, so it's just 67 millimeters up here. With this 67, I'm then going to divide that by 2 to give me 33.5. The plane now is sitting, as you can see on the model, 33.5 millimeters up. I've still not taken into consideration that 14, so I need to add that back on. So 33.5 plus my 14 will give me the centre of these two parts here, which sits at 47.5 millimeters. Okay, and I'm going to click on the green tick there, and that's my plane ready to sketch. Okay, I'm now going to go normal 2 on this plane. So the plane that I've got over here now that I've created, I'm going to left click on it and go normal 2. I'm going to go to sketch. I'm going to draw a centre line from the centre here up like so, and I know that the top of that centre line down to the bottom edge here is going to be 51 millimeters. From here I'm going to produce 2 circles. Let me just show you on the engineering drawing. So I'm just going to zoom in here. So there's 2 circles. This one here has got a radius of this one here has got a radius of 19, so a diameter of 38, and this one here, okay, is actually shown here as well, and it shows me that there's two of those and their diameter of 1905 to 1895 tolerance, so we're going to make that at 19. Okay, so grabbing a circle, first one, second one, smart dimension the outer one at 38 and smart dimension the inner one at 19. Just going to close off this sketch now by going to line. Just going to drop a line down from this quadrant down to the top of this line, across until it matches up with that, and then left click again. Okay, Control 7, and you can see that that sketch has been closed off and it's ready to be extruded. So the next step is I'm going to extrude this. So features and extrude, and I want to be extruding the regions here at the bottom, mid-plane, and let me just check the distance for that. Just going to zoom in onto my drawing here. Okay, so I've got the 19, the 29 and the 19 here, which create 67. However, I have got a 3mm bit here and a 3mm bit on this side, so it'll be 67 minus 6, okay, it will be 61. I'm going to flip back into SolidWorks. I'm going to do this distance here, D1 at 61, like so, and green tick. So I'm now going to reuse that sketch in here, and I want to create an extrude of this circle here, and I want it to be 67 this time, and mid-plane, and green tick. Okay, for the next step, what I'm going to do is I'm going to look at cutting out a section here, so you can see it here. Okay, so I'm going to draw on this face here. I'm going to draw out pretty much a rectangle and cut that through using these distances. So I've got 19 here, I've got my 25 here, so I can use that to my advantage. So I'm just going to nip into SolidWorks now, click on this face, normal 2. I'm going to sketch a corner rectangle. Like so. I know the distance from, just zoom into the model, okay, so from the center of this circle to the bottom is 25. So if I draw a center line, which is there, smart dimension from that line to here, I know that this needs to be 25. I know the distance from here to this line is 19. Like so, and then I can just cut through all on this. So if I go to features, extruded cut, and through all, and green tick. One thing I just forgot to check was a certain distance, so I'm just going to nip back into this sketch, and I just want to go Control 8 on my keyboard, and I just want to check that this, okay, that should be 29, okay, and green tick. Okay, you can see that here on the model. I'll just zoom in. You can see this gap here was 29. Okay, exit the sketch, and there we go. Okay, so the final thing that I've got to do there is put in some fillets. So I'm going to go up to fillet, show you here on the engineering drawing, we've got some 6mm fillets here, so radius 6 here, where it comes up, here, where it goes to its 90-degree angle, so there's 2 there, and then there's 1 here on this corner, and 1 on the other corner as well. So let's go ahead and put those in. So we want standard fillet, 6mm. We want one here on this edge, one on this edge, and one on this edge, like so. Green tick, fillet again, this time 3mm. I'm going to click on this face, just cross out of that, fillet, 3mm, click on this face, like so, and we want this face here, and we want this face here, and then green tick. So we need to put some holes in the top of here. So if I just go into my engineering drawing, I'll just show you. I have clipped the dimension off here, okay, but these circles are diameter 5. Okay, so it sits 9mm from the back face, 9mm from the front face. There's 2 of them, and they sit central on that particular shape at diameter 5. So the way that I'm going to do that is I'm going to go to my top plane. I'm going to go reference geometry plane. I'm just going to move this up just so that it sits above these. So this is fine, 77.5 is fine. I'm going to click at the green tick, go to my plane 2 and normal 2. I'm going to draw a center line just through the middle of these shapes here. Pop in 2 circles at 5mm diameter so I can make these equal. So if I hold down the control key, I can select them both, make them equal, smart dimension one of them at 5, and then I know from the face here to here was 9mm, and I know from this face to here was 9mm, like so. Okay, and I'm going to go to features, extruded cut, and I'm going to cut up to surface. I'll click on this surface here, okay, like so. Green tick, and there we go. Control 7 on my keyboard, and I can hide the plane as well. So just click on this plane and choose hide. And then a few things that we need to do to finish off. So it's saying that we need ABS polycarbonate with a density of 1070, working to 3 decimal places, and what is the overall mass. So let's go and right click, edit the material. Let's find plastic. We want ABS PC with a density of 1070, which is this one. We can apply that and close. And then from here we need to find out what the weight is in grams to 3 decimal places. So we're going to go into the evaluate tab, into mass properties, look at our mass, and there it is in grams, however it's to 2 decimal places. Go to options, go to custom settings, up this to 3, OK, and then there's our mass of our part to 3 decimal places, 376.412. I hope you found that useful. I hope you found it beneficial. This has been Solidworks Station. Please don't forget to like and subscribe, and if you're new to the channel, then you can always give me a big thumbs up if you're enjoying the content that's being produced. Thank you very much for your support, and see you again soon. Goodbye.